Okay, today we are going to discuss the classification of solids. Classification of solid according to energy band diagram. According to energy band diagram. So according to energy band diagram, if we talk about conductors, so for conductor, the conduction band and the valence band, they almost overlap each other. That is, the energy gap between conduction band and the valence band, this one is the valence band, VB is the valence band, and this one is the conduction band. Okay, so the energy gap is almost zero. This energy gap is almost zero. That is the conductivity, that is sigma is the conductivity for conductor. It lies in the range of 10 to the power 2 to 10 to the power 8. So as the energy gap is almost zero, so the electron can easily jump from valence band to conduction band, and there are so many electrons are in conduction band which are free to move and mobile, so they can easily conduct electricity in case of conductors. Whereas in case of insulator, if we talk about insulator, the conduction band is higher energy state and the valence band is lower energy state. As the conduction band and the valence band energy gap is very large, that is greater than 3 electron volt. So it is almost requires very high electric field so that electron jump from valence band to conduction band. So there are very few electrons in the conduction band, so it conducts very less electricity. So the conductivity in case of insulator is almost less than 10 to the minus 11 ohm meter inverse. Whereas in case of semiconductor, which is in the between conductor and insulator, semiconductors, the energy gap between conduction band and the valence band is less than 3 electron volt. This energy gap delta Eg is less than 3 electron volt. Generally it is 1 electron volt. For example, silicon and germanium. For silicon it is 0.7 electron volt, and for germanium it is 0.3 electron volt, and its conductivity lies in the range of 10 to the minus 6 to 10 to the minus 5, that is plus 5. Okay, now